Hydroelectric power is one of the most widely used and cheapest ways to generate electricity today. By 2004, 6% of the world's electricity was hydro. Some of that generated in enormous gigawatt-rated hydro power stations in Asia and Australia, and also the largest power plant in China. However, the operation of hydropower stations, for example the construction of dams, represent a substantial disturbance to the environment and local communities. But these hydro dams, for the most part, are pollution-free. This is a real-life documentary based off real events. This is Hydroception. So here we are at the Vancouver BC Hydro Building, and we're looking for someone who can tell us a little bit about hydroelectricity. Mr. and Mrs. P.H. Dean, can you tell us something about hydroelectricity?
Well, hydroelectricity, or also known as hydroelectric power, is electricity gathered by harnessing the power of water that flows down from a higher up level. It is a timeless and constantly a renewable source. Huge generators convert the potential energy of falling or fast-moving water into something called electrical energy. The obtainable energy of the water is first converted into mechanical energy and second converted into electrical energy. My wife here will continue.
You see, water is usually stored in dams, is let down through large pipes or tunnels in the lower levels, and in the course of the fall, the water rotates turbines. The mechanical energy produced is converted to electricity by using generators connected to it. Combine two and two together, the structure with the turbines and generators, and we call that the powerhouse. When people think about the formation of electricity, they mostly think of dams.
So how much electricity do these dams produce?
Well, 80% of BC Hydro's power comes from the Peace Columbia rivers, and that produce 29% of BC Hydro's electricity requirements.
Thank you, Mr. and Mrs. Dr. Ph.D. So now we have some dams to investigate. Here are the basic components of a conventional hydropower plant and how it works. The dam is what a hydropower plant mostly relies on. It holds back water, creating a large reservoir. The water in the reservoir is considered stored energy. Often the reservoir is used as a recreational lake, such as Lake Roosevelt at the Grand Coulee Dam in Washington State. The intake is when the gates on the dam open, then gravity pulls the water through the penstock, which is a pipeline that leads to the turbine. Water builds up pressure as it flows through this pipe. When water strikes, it turns the large blades of a turbine, which is attached to a generator above it by way of a shaft. The most common type of turbine for hydropower plants is the Francis turbine, which looks like a big disc with curved blades. A turbine can turn at a rate of 90 revolutions per minute. As the turbine blades turn, so do a series of magnets inside the generator. Giant magnets rotate past copper coils, producing alternating current by moving electrons. The transformer inside the powerhouse takes the alternating current and converts it to higher voltage current. For the power lines, there are 4 wires that come out of every power plant, the 3 phases of power being produced simultaneously, and the other wire is a neutral or ground common to all 3. The outflow is the used water that is carried through pipelines called trail races and re-enters the river downstream. And that is how a hydro dam works. Well, my partner in deducing has mysteriously disappeared, but she'll be back. In the meantime, we have the Lorax, protector of the trees, telling us all about the disadvantages of hydroelectricity. Can we make this quick? I have to deal with these chaotic protesters. They want to cut down my tephila trees for their damn hydro dams. Sure thing, Mr. Lorax. Can you tell us a few things about the disadvantages of using hydroelectricity? Oh man, there are many downsides that come to mind when using hydropower. First, hydropower dams disrupt the natural flow of rivers. This alters the river and several habitats. Habitats become separated, destroyed. Fish are unable to go to their spawning grounds. Even the animals that eat fish lose their main resource of food.
Also, the money. This is usually a common thing to expect from renewable energy. Dams are not cheap to build. A lot of effort and materials are required, and extreme safety measures are considered for assured safety. Most importantly, the dams have to be built somewhere, and that somewhere is where my trees are standing. People cut down the trees and use the area for their hydro dams, and it's damaging the environment and harming habitats.
Thanks, Lorex. Well, we gotta run now. I think we've got exactly what we need. After all the research we've done, we found many advantages as well.
Okay, so let's look at the advantages of hydropower. Producing electricity through hydropower does not harm the environment, unlike burning fossil fuels like oil or coal. Hydroelectricity is generally quick, safe, and doesn't produce any waste. Water that has been stored in dams can be used whenever needed, so it runs faster through that method. When electricity is produced by the dam, systems do not produce greenhouse gases. Therefore, they do not pollute the atmosphere. Once the dam is built, the electricity is free, so no waste or pollution is produced, and electricity can be generated constantly. Also, there's a lot of extra energy to save and use.
Worldwide, hydropower plants produce about 24% of the world's electricity and supply more than 1 billion people with power. The world's hydropower plants output a combined total of 675,000 megawatts, the energy equivalent to 3.6 billion barrels of oil, according to the National Renewable Energy Laboratory. There are more than 2,000 hydropower plants operating in the United States, making hydropower the country's largest renewable energy source. Demand for electricity is not flat and constant. Demand goes up and down during the day, and overnight there is less need for electricity in homes, businesses, and other facilities. Hydroelectric plants are more efficient at providing for peak power demands during short periods than are fossil fuel and nuclear power plants, and one way of doing that is by using pumped storage, which reuses the same water more than once. Pumped storage is a method of keeping water in reserve for peak period power demands by pumping water that has already flowed through the turbines back up a storage pool above the power plant at a time when customer demand for energy is low, such as during the middle of the night. The water is then allowed to flow back through the turbine generators at times when demand is high and a heavy load is placed on the system. The reservoir acts much like a battery, storing power in the form of water when demands are low and producing maximum power during daily and seasonal peak periods. An advantage of pump storage is that hydroelectric generating units are able to start up quickly and make rapid adjustments in output. They operate efficiently when used for 1 hour or several hours. Because pump storage reservoirs are relatively small, construction costs are generally low compared with conventional hydropower facilities.
So we finally found all the information we need for our documentary, and I guess this is it for us.
You mean, I found all the information for my documentary.
What are you talking about?
I think you know what I'm talking about.
No. What are you doing?
Ah! Yes! All the information is mine! Who are you? Ah! No, who are you?
Now the information can never get out.
Avenue, and then we'll take it higher. Oh, we're gonna rock down to Electric Avenue.